Good morning, everyone. So we are at home today, and I'm going to go ahead and do what we would have done if we were in school. So starting with solving by taking square roots. This would have been your warm-up. So I'm going to do this with you. Afterwards, you will have some questions on your own that you need to answer, and you will do that on a separate sheet of paper and then answer online. But first, let's review how to solve by taking square roots. First thing, we have a quadratic here that has an x squared value but does not have an x term. In other words, it does not have something with just an x to the power of 1. That is a clear indication that I can solve this by taking square roots. This one on this side is a different kind of square. It has a binomial. That means there are two terms inside parentheses and it's squared. I can use square roots to solve that too. We've done this before. You've already answered questions on these. You've done homework on it, but let's go back through it and do it again. So this first one, we always want to make sure that our x squared term is isolated. So we're going to add 3 to both sides. And then we will have x squared equals 13. And now I can take the square. Sorry, let me get rid of that. I can take the square root of both sides. And remember, when I do that, I have to add a plus minus in front. Now, we always want to make sure that if we can, we do simplify that square root, but 13 is prime. That does not simplify. So this is actually our answer. Our answer is a positive square root 13 and a negative square root 13. Okay, this other one, we want to do the same thing. We want to isolate this perfect square. So I'm going to have a plus 3 here. Oops. And I'll have x plus 2 squared equals 13. Okay, and then I'm going to take the square root of both sides. Now, when I take the square root of anything that is squared, remember, what is inside the square root, or what is the perfect square here, becomes the answer. So if I square root a square, the x plus 2 no longer has a square on it. We've undone that square. And on this side, I have just a plus minus square root of 13. Now, that square root of 13, again, is not going to simplify, but I still need to solve for x, so I have to subtract the 2. So what I'm going to do here is I'm going to separate this into 2 equations. So it'll be a positive square root of 13 and a negative square root of 13. Okay, because remember, that's a positive 13 and a negative square root of 13. I'm writing them together. So what I'm going to have here is a minus 2, minus 2. Now, I cannot combine a whole number or an integer with an irrational number. So I have x equals negative 2 plus the square root of 13. And remember, this is a complex number. It has an irrational part and a rational part. I'm going to do the same thing on this side. X equals negative 2 minus the square root of 13. Now, I split this up to show both answers, but the truth is you could have given me right here where I split these two, you could have told me negative 2 plus or minus the square root, and I did that upside down. I do that sometimes. You'll have to get used to it. I could have given that answer as well. In fact, you're going to see that when we do the quadratic formula. You will see the plus minus and both answers listed together, but I want you to understand that those are 2 different answers. So now you're going to have some questions that you need to answer yourself on the computer on your own, and you need to give me your answer. You can do that now. Then we're going to go down to, is it a perfect square trinomial? We're still warming up. We haven't learned what we're learning for today, which is completing the square. But we are looking at this first one, 4x squared minus 16x plus 16. First, what is a perfect square trinomial? A perfect square trinomial is something that can be written like this: a squared plus 2ab plus b squared, or it can be written a squared minus 2ab plus b squared. So it will always be plus b squared, but it could be a plus or a minus here. So when you're looking at these perfect square trinomials, or these trinomials that might be a perfect square, the first thing you need to figure out is, do I have a perfect square in the first term and the last term? And every single one of these does have a perfect square in the first and the last term. But that doesn't make them automatically a perfect square trinomial. And that is a big mistake I know a lot of people do or you think that just because it has a first and a last term, that is a perfect square, that it is therefore a perfect square trinomial. It's not. So what I want to show you here is how we can determine whether or not that it is a perfect square trinomial. So let's take a look at this first one. First thing you have to do is figure out what is being squared. Well, the square root of 4 is 2. The square root of x squared is x. This is 2x squared. This 16 is 4 squared. Okay, so if I'm looking, then I know these are both perfect squares, but is the middle term the right number to be a perfect square trinomial? The way that I figure that out is just multiplying 2 times a, which is the 2x, times b, which is the 4. So in this case, I have a minus 2x, and 4. If that is the same number, then this is a perfect square trinomial. So if I multiply 2 times 2, that's 4, times 4 is 16. This is a perfect square trinomial. Yes. And if I wanted to write that then as a perfect square, the way I would write that is 2x minus 4 squared. Now, this might be where I'm losing some of you, where you might not really understand what it is that I'm trying to do. Let me show you what we're doing here. Let me get rid of all of this first. Okay. So just to prove to you that this is the same thing, feels like we're at school. I'm moving things all over the place. Hold on one second. Okay. What this means, put that in the wrong spot, is 2x minus 4 times 2x minus 4. And if I FOIL this back out, 2x times 2x is 4x squared. 2x times negative 4 is negative 8x. Inside terms are negative 8x. Outside terms are plus 16. Do you see how we're never going to have a minus on this side if it's a perfect square trinomial? This is then going to simplify. These two middle terms will add together to 4x squared minus 16x plus 16. This is a perfect square trinomial, and it factors to 2x minus 4 squared. Now I'm going to get rid of all of this stuff that we did for FOILing, okay, just so you can see this part. And then let's take a look at this next one. We have 5x squared, or we have 25x squared, which factors to 5x squared. This is 3 squared. So let's check this. I have a plus. If I put a 2 in there, because that's part of the formula, and then times the 5x times the 3, then I will have a perfect square trinomial. If this is a perfect square trinomial, it has to be the number that I have just created in the center. 2 times 5 is 10, times 3 is 30. This is not 30. It would have to be 30 in order for that to be a perfect square trinomial, and it isn't. So this is not a perfect square trinomial. So this one is not a perfect square trinomial. So let's go down to the last one. We have an x squared and a 4. The x obviously is just x squared. This is 2 squared over here. Minus, because that's a minus, we have a 2 automatically in the formula, and then I take the a and the b. So that's x, and the b is 2. Now we're using a and b for these, which gets a little confusing with what we're about to do, because in quadratics we have a, b, and c. They're not the same a, b's. But this is negative 4x. So this is a perfect square trinomial. This actually factors into x minus 2 squared. X being the a, minus because there's a minus right here, 2 because the last term, when we take the square root, is a 2. And that's where that comes from. Now that's going to be really important for what we're doing today, so I wanted to review that. Now I'm going to put a few things up that you need to then factor. You need to check and see if it's a perfect square trinomial, and then factor it if it is. So what we're actually learning today is solving quadratics by completing the square. So the first thing that I'm going to have you do is to write down solving quadratics by completing the square and all of the instructions that I have written right here. And I'm going to have you pause the video and write that in your notes. You do need to put this in your notes. I don't know what page we're on, so you guys all need to figure that out together. I'm not sure. So go ahead and write these instructions in your notes, and then we will follow the instructions after you have those written down. So what we have here is x squared minus 4x equals 5. Now I actually could solve this by factoring. I would move the 5 over, I would set it equal to 0, and then I can factor it. This one could be done a different way. We're going to use it to show you completing the square, though, because the completing the square and solving with the quadratic formula, those problems can get pretty complicated and the answers are complex. It's easier to start out with something that comes out with a nice round number answer. So we're going to use this one instead. But what we have here is x squared minus 4x equals 5. You'll notice I don't have it equal to 0 this time, because when we are completing the square, we don't want it to equal 0. What we want is to be able to do what we did on the last page, which was solve by taking square roots. So we need to create a perfect square trinomial on this side, on the left side. So these are our instructions. Sometimes it's just easier to follow the instructions, and then you will remember after you've done these a few times exactly what you need to do. You won't need the instructions. I do not want you to memorize them. It's just meant to be a guideline. So the first thing that you need to do is make sure all the x terms are on one side. And if you look at what I have here, our x terms are on one side. So I have this x term and I have this x term. And on the other side, I have my constant term, or my 5, okay? So that's the first thing. You want to make sure that that has happened, and we have done that. So check, that's done. Then we want to divide out the leading coefficient. Well, the leading coefficient is always whatever is on x squared. And right now we have a 1. We don't need to divide a 1 out, okay? That's not, if it's a 1, that's exactly what we want. We don't want to have any other number besides 1. If you look down at the next example, you'll see there's a 2. We're going to have to deal with that in the next example. So in this case, we have already divided out the leading coefficient. Now, this is the part where it gets tricky, okay? Remember when we have a quadratic, we have ax squared plus bx plus c, right? This c is not technically 5 because it's not all on the same side. But the a and the b, because the a and the b are together on this side, this is a, 1, and b is 4, or -4 in this case. But we don't care about the negative as much in this case because it's going to be squared anyway, and we won't have a negative or a positive. So the b is 4. We're going to take that 4, and we're going to find 4 divided by 2, and we're going to square it. 4 divided by 2 is 2. If we square it, we get 4. Okay, so that is just this part right here, finding b over 2 squared. And I'm actually going to move that out of the way because I don't want it necessarily where we're working. We're just going to find it. And then the next thing is that we add it to both sides. So we've gone ahead and found it. We've done that. Now we have to add it to both sides. So we're going to add 4 to both sides. We'll have x squared minus 4x plus 4 equals 5 plus 4. We can do, as long as we're adding something to both sides, we can do that. It's just like solving an equation, although that's not why we're adding the 4 this time isn't the same reason we would add the 4 when we're solving a different kind of equation. This time what we're trying to do is create, if you look at this, a perfect square trinomial. Okay, so what we have here is a perfect square. We have x squared, we have x squared, we have 2 squared, and in the center we have 2, and we take the a and the b, right? And that will give us a 4, minus 4. Now we're not going to leave that there. I'm going to get rid of that. But what I wanted to show you was we just created a perfect square trinomial that, by the way, factors into, just like we did on the other page on our warm-up, factors into x minus 2 squared. X minus 2 times x minus 2. Now the other side of this is a 9. And this looks very much like what we did at the beginning of class, okay, where we were solving this equation right here, where we took the square root of both sides. And that's what we're going to do next. We factored into a perfect square already. We added to both sides, factored into a perfect square, and now we're going to solve by taking square root. So what we do is x minus 2 equals plus minus the square root of 9. Okay, this becomes x minus 2 equals plus minus 3. Now, don't try to solve this all as one equation because it won't work. You have to split this at this point into 2 equations. X minus 2 equals a positive 3, and x minus 2 equals a negative 3. And you will have, if you add 2, you get x equals 5. And if you add 2 here, you do not get x equals negative 5. You get x equals negative 1. And those are your 2 answers. Okay, so we've just solved by completing the square. So I'm going to have one exactly like this that has a 1 as a leading coefficient for you to try on your own. I want you to give that a shot. You'll have to do that before you continue the video. Then we'll do the next one. So I have recopied the same instructions below. You don't have to type those or write those again in your notes. I just wanted to have them there so that we can look at them. This is the next question that we're going to answer. This one you'll notice, number 1, it has a leading coefficient, and also the x terms are not on the same side. So the first thing that we want to do is to get those x terms on the same side. So I'm going to move the 6x to the other side, which makes it 2x squared minus 6x. The next thing I have